Our project is called GraphiPy. So GraphiPy is a Python library that enables users to extract data from different social media websites. So data generated by humans on social media is a goldmine for researchers interested in data science, social science, marketing, and business analysis. And we realize that gathering and analyzing such data from different sources, such as Twitter, Facebook, and Pinterest, is such a laborious task that involves learning and working with different APIs. So our motivation is to create a unified interface, which is GraphiPy, that um, provides simplicity to the users who want to extract data from social media websites. So GraphiPy enables users to extract data from different social media websites by providing a unified interface. So users only need to learn about GraphiPy instead of learning the different social media APIs. So we provide such a wrapper to simplify the data extraction. And we also support exportation as CSV files, when a user wants to visualize the graph using GV, for example, or Cityscape. So GraphiPy provides support to several different websites such as Facebook, Pinterest, Reddit, Tumblr, Twitter, YouTube, and LinkedIn, even though LinkedIn is still in progress. GraphiPy contains a data structure class called a base graph, in which endpoints in social media platforms such as users, communities, and posts are stored as nodes, and connections between the different nodes are stored as edges. We also have three different types of graph that inherited from the base graph. We're using dictionary, pandas, and Neo4j. For the dictionary graph, the type of nodes and edges are stored as keys, while the row of data is stored as value. But what makes this interesting is that the rows of data is also a dictionary with the keys as the ID of the nodes, and when the value will be the actual data from we grab from the different social media websites. For pandas, since inserting rows one by one into the data frame takes polynomial time, the implementation uses a dictionary to help. So the types of nodes and edges are stored as a key, while the data frames containing all the data in different rows are stored as values. And the way we implement this is that we have a buffer, and we count the number of dictionary elements that has been inserted. And after the dictionary has a certain amount of elements, it will be converted to the data frame and appended into the existing data frame. And for Neo4j, GraphiPy directly connects to the Neo4j database in your PC. And for Neo4j insertion, we use merge instead of create. So nodes with the same ID will not be inserted again. Instead, it will just update the existing data. So using GraphiPy, the user can export data as CSV files and visualize the graphs using NetworkX and Giphy. And this is an example code using the export path. So exporting the graph will provide the user with the path to where the files are exported to, so the user can know where the files are exported. And here we have example pictures of the graphs visualized using Giphy and NetworkX. So GraphiPy focuses on simplicity, while you need to learn about the different types of APIs. By using GraphiPy, you can grab the data using few lines of code. So for example, we have Twitter here. After you provide all the credentials, you can just call the fetch tweets by topic if you want to fetch the tweets by topic. Just provide the arguments needed for the query and it will return the results based on the keywords. So now we will show you how to use GraphiPy. Okay, so this is demonstrating on how to use GraphiPy to extract data from Reddit. So you'll need to connect to Reddit's API by providing the client ID, client secret, user agent, your username and password. And you can get the client ID and client secret from this page here. So just click on this button, fill in all the fields, click on the create app button, and it should give you the client ID and client secret. So let's say that I want to search for subreddits that contain the word Python. Just run this query here, and it will return a graph, but in this case it will only return the different nodes that contain the subreddits. So just have subreddit and no edges, and let's say that you want to get the subreddit data frame. You can do that like so, and you can see the attributes. These are all the attributes, and let's say you want to see only the display name. You can use this command here, and we'll show you all the different subreddits returned. And let's say that I want to search the submissions in a subreddit, which is the posts that are posted here. Let's say I want to search for the Python. Then set a keyword and run the function. And it will give you the subreddit, redditor, and submission nodes. So you can see it will return all the attributes of the subreddit and the submission and the redditor. So, and see the title here, they're the same, so it's real-time data. And you can also do the same with edges to see the different kind of edges, like so. And these are all the same different types of functions that you can do. So you want to see the submission comments. They're basically similar to each other, and this is also the same for the different social media websites, let's say Twitter and Facebook. You can also search for the comments of the Redditor, like so. You can then export the graphs as CSV files. You have two functions here. You can export all of them together, or you can just specify the nodes and edges that you want to export as CSV by calling this function and specifying the name, the set of nodes, and the set of edges, like so. And you can also visualize your graph with Network X. So GraphiPy has an exporter object. It has built-in functions that will draw the graph for you, draw random, which will draw the graph with random colors. But you need to provide the set of colors, and for this case, I'll be using Matplotlib's built-in colors. And you can set the label that you want to be on the nodes and whether you want to color for edges or not, like so. So this graph here only has one color for the edges, and if you set it to true, it'll have color for edges and it will label the different edges by color here with a legend. So that is all for Reddit. Now for exporting graphs and visualization, so basically I did the same thing as before, but now we have three types of graphs right here. Before we use the pandas graph, so if you don't give the function any arguments, it will default to pandas. But if you put in the arguments here like dictionary and neo4j, then it would create a the graph with that type. And for neo4j, you will also need the authentication, and it will pass it as a second argument here. but they're basically the same thing as before, and they have the same functions. Let's say you can get the nodes like so, or but if you want just one type of node, neighbor.j is a little bit different. You can just call get node instead of get nodes and specify the type of node that you want to get from here, like so. And now for visualization with network X, it's going to be similar as before, but um, for different sets of graphs, just so first you have to call the exporter object, and for each type of graph you have different functions. Let's say for dictionary you do create from dictionary, and from pandas you create from pandas, and then same for J. And now for drawing the network X graph, um, you have the options for on how to draw a graph. And so let's say if you want to have labels, let's say you can add node label, it's a label attribute. So when you draw the graph like that, but it's kind of hard to see, so I'll just leave that off. And you can also do the same with edges, so each label like so. Yeah, but it's a and you can also have colorful edges. I'm gonna remove this for now because it's kind of hard to see. Let's say if you set the colorful edges to true, then you'll have colorful edges. See, you have four types of edges with different colors, as opposed to this graph, which only has one type of edge. So basically, you have four options to set, which is the node label and the edge label, which are missing from here currently. Gonna add that. So yeah, you have four options here, and you can also export graph as CSV files, like so. And the functions here will return the path to where the files are exported to. So yeah, let's say for pandas, it will return the path to where the files are exported, which is here. And also you can convert from one graph type to another. So let's say from dictionary you want to convert that to pandas, just call the convert graph function, and the first argument will be the original graph, and the second argument will be the type of graph you want to convert it to. And also for neighbor.j, if you haven't authenticated already, you'll need the authentication argument right here. And remember that we got the path to the CSV files from here. And if you want to use CSV files with network X, GraphiPy also provides the option to do so, to create a graph from CSV files. Just provide a path to where the files were exported to. But if you want to use your own CSV files, you will need to have a specific folder structure. So you'll need parent folder and the nodes folder and the edges folder, and the respective CSV files inside the folders. So your nodes CSV files should be under the nodes folder, and the nodes and edges folder should be under the parent folder. And you can do the same thing and draw the graph for the CSV graphs, like so.